Hello, welcome to my YouTube channel. Today our topic is about microservice, routing and filtering with Spring Cloud Zuul. In this video, we will use Zuul as a load balancer and implement an API gateway pattern. A more in-depth tutorial about Zuul is available on my video with the title Microservice Spring Cloud Zuul Reverse Proxy as Service Gateway. For this video, we will show how our projects fit together and demonstrate a partial working Spring microservice architecture. Remember, we are building a catalog and inventory management system by leveraging the Spring Cloud. Here is how our current catalog and inventory management systems architecture look like. We have the Terra Warehouse catalog and Terra Warehouse inventory. Both are microservices. They are fetching data from the Terra Warehouse config server, and both of them register to the Terra Warehouse service discovery for client discovery. Here we have the Terra Warehouse gateway. This is our API composer, which joins the query or joins data from two different microservices. As catalog has its own database as well as the inventory. That's why when we need data from both database, we need to do the join in a separate or another microservice. And this is the Terra Warehouse load balancer, which is powered by Zuul. This is the project exposed to the client. Needless to say, the services from the catalog, inventory, and gateway are not accessible to the outside clients, like for example, we have a mobile or web client. Now let's start running the code. But before running the code, I will first show you the project composition. We have the Bootcamp Commons and the Terra Warehouse set of projects. Both of them are available from GitHub. This is Bootcamp. It contains two projects, the Bootcamp Utilities, which contains utility classes, and Bootcamp Commons that contains the common models, DTOs, and API classes that we are using. I created a separate project because we will be having several microservices, and it will be easier to reuse if we have a common project. And then the Terra Warehouse group of projects. First, you need to clone the Bootcamp utilities and run Maven install. Do the same with the Bootcamp Commons. It's a multi-Maven module projects. That's why when you import, you should have 4 other projects, because inside the Bootcamp Commons, it contains these modules, the model, DTO, and API. And then we need to check out the Terra Warehouse projects. We need to run the projects in this order. The Terra Warehouse config server in Node 1. Node 1 is running on this machine with an IP of .101, and Node 2 is running on IP .100. Again, we need to run the config server on Node 1, discovery server, as well as the load balancer. And run the second group on Node 2, the catalog, inventory, and gateway. Since I'm using this computer is Node 2, meaning I cannot show the Node 1. It's running on Ubuntu. I have already run Maven install and run this applications on Node 1. Remember, I'm using Java 11, so make sure that you have Java 11 installed on your machine before checking out these projects. This is the config server. We don't have any properties defined in the local Git where the config server is running. That's why there is no property here. We are using the properties defined inside the source test resources folder for easier demonstration. And then this is the Eureka server where our microservices registered. When a client calls a URL from the Zuul server, it will route to this URL. For example, if we call the catalog, if we send a request to the catalog URL, it will forward the request to the catalog microservice. And to look at the catalog microservice, it will look at Eureka. Eureka will then match the Spring application name and pull the IP address. Again, let's look at the routing configuration. The routing should be available in the load balancer project. Here are the routing configs. We are routing gateway to gateway, microservice, catalog to catalog, and inventory to inventory. One thing to notice is the add proxy headers. We need these for hate OAS. And then we prefix with API. That's why later our request URL will have the API, but it will be stripped. That's why only the succeeding part of the URL will be matched in the routes as API gateway. So gateway will be the path that will be matched. As I've been demonstrating, this is the config server, Eureka, and the Zuul server. The routes should be accessible in the actuator routes URL. And then we have a node to the catalog, inventory, and API composer. I have already run the 3 microservices, but again, to do so, you must check out the 3 projects in your local machine and then run Maven install. And by the way, before you run Terra Warehouse catalog and in this machine and Terra Warehouse config server on the node 1, you first need to download or to clone and run Maven install on the Terra Warehouse BOM project because it contains the version of the dependencies needed by the other microservices project. Now let's do some testing. To make testing easier, I created a Postman Collection. Postman is a client that you can use to send REST requests. The test project is available under Source Test Resources folder, Terra Warehouse Postman Collection. You need the environment project as well. Import it in your Postman. And that project, once imported, should look like this. We should just focus on the inventory folder, but we cannot run the folder as a collection because we will not see each of the requests, and we need that to demonstrate how it works. First, we create the category, the brands. As you can see, there's a hate OS here, and the URL is pointing to the Zuul or load balancer server, not the category microservice. Okay, let's continue running our test. This is for the manufacturers. Create Manila. This is dealers, and then we will get the ID of the locations. By get, I mean we are fetching the data and then we are saving the ID of the record we are interested in. It's obvious that I'm living in the Philippines, right? And now we will be creating the locations where this provider is doing his or her business. And finally, the branch. Again, this request handled by the catalog microservice and this one by the inventory. These are the commands that we use to create a product stock. And we have some basic error handling as well. This one is a duplicate of the previous request. That's why we have a serial number and warranty card number exception. And finally, I think this is the most important request in this collection, the find stocks by product ID. When we send the request, it will go to Zuul and Zuul will route to gateway. Now, the gateway will act as a client that will, so it's an open pane client, and it will send or forward the request, proxy the request to the catalog microservice to get the product detail and to the inventory microservice to get the product stock detail. because we will be requesting a list of product stocks with product code. But remember, product code doesn't exist in the inventory microservice. And thus, again, looking at the product stock gateway controller, we can see here that first we get the product detail from or using the catalog microservice or catalog proxy, and then we get the list of product stock using the inventory microservice or inventory proxy. All the codes are available in GitHub, so you are free to download, clone them, and do your own testing. I think it would be better if you do that so that you will get familiar with the microservice architecture and how it works, and hopefully you can apply it in your future project. And I think that's all for this video. I hope I was able to impart some part of my knowledge and that you could use it in your future endeavor. Please support my channel by subscribing to my YouTube channel and hit the bell icon to get notified when I upload a new set of videos. I think next we will discuss his tricks and some reporting and possibly how to deploy using Docker and Kubernetes. I hope to see you on those new set of videos. Again, thank you for watching. Have a nice day and goodbye.